Okay, hi everybody. So today I'll be talking you to give you a tutorial on how to basically use Pavlovia and also how to get data from Pavlovia, then clean it, and then also do a first analysis. In terms of Pavlovia itself, I'm going to assume you already know how to get stuff on Pavlovia. But if not, what I would recommend is this tutorial by this guy called Jordan Gallant, who has a playlist called Open Office Hour 2, PsychoPy 3, GitLab, and Pavlovia Basics. And I think especially the first 3 videos will teach you like how to, how Pavlovia works, how to make an account, how to then upload your PsychoPy project, and then also if you want to share and basically get comments, but especially the first 3 are very important to watch. So whatever you learn in the tutorials, like I would still, of other people, like I would still recommend you watch these videos. I don't know who this guy is, but he basically taught me how to do it last year. So, and then of course, when you have your experiment itself and basically you make a link between your PsychoPy experiment and a Pavlovia account. And then all you need to worry about after, if you have to change something, is these 2 buttons here. So instead of like display button for local PsychoPy running, now you can use this globe thing. So like, what does it say? Like run the study online with Pavlovia or sync with web project. And so that will basically like allow you to push your experiment onto the cloud, onto the server of Pavlovia. And then you have to say like what you changed in a Git comment. That part is actually like the easiest part of using PsychoPy and Pavlovia. So you might run into some problems if you first run Pavlovia. Maybe some commands from PsychoPy didn't translate well because PsychoPy uses Python, but online they actually use JavaScript, Psycho.js. So there might be some kinks there that you need to like iron out. Anyway, I hope you can figure it out. If not, I don't mind trying to look at it for any team. But yeah, I will do my best also. So imagine, hey, you've run your experiment, and then you go on Pavlovia, this website here, and basically you want to get the data out of it. So what do? You go to dashboard, where you have like a nice profile, then experiments. You see, these are many experiments I've run. For instance, memory Korean. Please wait. Okay, so because you're like, I'm assuming you already run it, but still, like, this is kind of what you would get. Like, you have like 3 kind of statuses: inactive, piloting, or running. Piloting is when you want to test it. Running is when you actually run it, but you need credits for that as well. This one finished, so I put it on inactive, but you can still download the results, best in a CSV kind of way, like so. It will give you some warnings about like how to wait for it to compile. And after you're done waiting, it will tell you, do you want to save this memory Korean? It's in a zip file. Here you can see it's a zip file, which you can then open, and then that will give you lots of CSV files to work with. I'm gonna cancel here. Okay, so depending on how you worked on your how you like presented your PsychoPy experiment, like if you put conditions into 1 file or into 2 files, you need to start cleaning, because any data project basically, you will have your data that you will need to import. You will need to tidy it, clean it, and maybe transform it as well. And then it becomes useful to visualize stuff, to model it, and to communicate, to learn stuff from it. So these are kind of like discrete steps. So I'm assuming you were able to get data, to fetch it. It's on your computer, but it will kind of look like a mess. So the case study I'm using is also a project kind of similar to the one you're doing, which involved a vowel harmony and a vowel disharmony condition, which was run separately. And these are 2 CSV files. So I kind of like made it smaller. These are 2 CSV files that basically were spit out by CyclePy or Pavlovia. And as you can see, like, it looks like this, right? So like you have like this like top line here. Then you have like a really long line with participants up all the way down. For step 1, because it was also in phases. Step 1, phase 1 is kind of the same. You have a block here. After that, like some like transitioning stuff. Then step 2. Okay. Then step 3, a block of data. Step 4. And then finally, there was also like a test at the end. But as you can see, like this kind of like values like circle 5A or whatever, like that's not very meaningful. So it's good to spend some time cleaning your data. So it's, you know, like nice and easy. For instance, like we don't want like these like brackets, these like quotation marks. We probably just want A, B, C, like in and also like, what is this mouse 5 click name? What does that mean, right? Like, imagine yourself in the future if you would ever want to like come back to this project, or maybe somebody else wants to replicate it. This name, mouse 5 click name, doesn't really mean anything. It's better to give it a meaningful name. So that's why we kind of need to clean the data. And we also need to clean it in such a way that like all these different files, I've only put 2 here instead of the original 45 for this condition, kind of all are compacted into one single file. That will be easier to just load in, right? Because you just need to load in one file. Technically, you could also have all these cleaned like 45 files and then use some kind of loop to just like every time read it in, but why do 45 if you can also just have one? I'll just walk you through like the way I would do it for, yeah, I did it for this project, and like, I hope you can get some takeaways from it. I do hope you have some kind of basis in R, because that's kind of what I'm assuming. But even if you don't, try to follow along for the logic of of like the cleaning process. Like, should you be able to use like Python or some other like programming language, then feel free to use that as well. But just, you know, like, try to follow along for the logic. You could also do it manually, but then that kind of risks, you know, like introducing some kind of errors, which is kind of like the problem with Excel, or a problem. So usually Excel is very good for like quick computations or like quick changings, or like if you have to like change your data here and there. So like as a source file, it's really useful. Most computers, especially at universities where they have the licenses, have it installed. But if you were then to like replicate it, like what you kind of miss, you know, the formulas in like on top, like equals sum of blah, blah, blah. Those things kind of get lost. So it's better to have a script. So next time, like the next person, if you hand them the exact same script, the exact same data source, they should be able to get the exact same results. So I am assuming you know R and RStudio. So as you can see, the version here I'm using is 4.1.3, effectively titled One Push Up. Our studio looks, well, mine looks kind of like this. The colors don't really matter, but this is what I like. If you don't know how to, if you don't have this on your computer, it's open source and it's free. So there are enough tutorials to help you like install it. So please find them. Pause the video if you are interested in it. Okay. So the first thing I'm also assuming is you have a kind of like a folder in your computer called tutorial, or that's what I call it. Like, you don't have to call it like this, but this is where you will be doing like your data analysis. So you have a folder called data, in which there are two separate folders in this case, with the CSV files fetched from Pavlovia. Pavlovia also spits out some other folders like log files and stuff. You don't need to worry about those per se, and you can also have them here, like, but for clarity's sake, I just did two. I also didn't change the names of the files, so it's this like 7-2021-12, right? So we ran this on the 4th of December, and this time, okay. What we want to end up with is something that kind of looks like this. So a major group, or like a vowel condition, right? Vowel harmony. You can see like suddenly it will become disharmony at some point. We want to clean the participant names so that we have harmony 1, harmony 2, disharmony 1, disharmony 2. The timestamp we just kind of kept. There's all these NAs, but basically it's all of the different blocks from before, right? So you can see that there is like a block here, another block here, another block here, and another block here. And then like that gets repeated across these different participants, because that will be the best way to just basically like do the analysis. So that's our goal. This is our source. This is our target. Let's make it. So I also have a folder here called scripts, which I will share later. So, or I'll probably add them to like the link or something. Anyway, so you have something like to just copy and paste and try to like adapt to your own data. Okay. I think also the easiest way is to kind of make a project. So what does that mean? Well, let's say you're in RStudio, you make a new project here. If you don't have this folder yet, you can use the first option that I will give you. Come on. So a new directory. In this case, I already have a folder with this data, so like I'm just going to use existing directory. Okay, so what I was saying is you can have the existing directory, or like in this case, or a new directory. Or if you have a GitHub project, you can just link to that one. That's the third option. In this case, we're just going to do it locally. So desktop tutorial, that's where I put it. So create project. RStudio refreshes. Oh, okay. This is a surprise for in a second. So what happened here is this rproj file appeared. So that one basically will act as kind of anchor. And so every time we make paths, we can just do it relative to this R project file thing. If you would look inside, basically it's just a few lines of code saying like, this is where your project starts. Okay, you can also inspect it here on the side. So there's like a hidden file, our history, data, scripts, and this R project. So that's kind of like what it looks like, pretty bare bones. It's useful to also make a figures folder if you want to save your figures. Maybe I'll do that already. Figures. By the way, in the corner here on the left, you can see what I'm typing. So KKKKK, right? Okay. So let me first close some windows because it will be easier. Okay. Fine. Then, well, we'll start with cleaning, the separate step of cleaning. It's also good to just restart R just to make sure you have like a new session open. So packages I'm using are the tidyverse package. I don't really write that much base R, if that makes sense to you. So like the kind of functions I use are pretty easy to use, I feel. The here package, what does that one do? Well, basically, it makes you use relative paths instead of using absolute paths. So instead of writing a path like, you know, it's like users, Thomas, blah, 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 which on Windows should become users like with the other way around. And this will always lead to problems if you want to hand your whole project to somebody else who is working on a different system. So the here package kind of like prevents that. Another one is the FS package, which is useful for loading in multiple files and listing them, but not super necessary. But I'm also assuming that you know how to install packages, but in case you don't, there are two ways. Either in package, you can just use the install wizard, or you can also just type into, oh, I guess I should probably write in the console here, install packages, tidyverse, for instance, right? And then it will install. Okay, so let's load those three packages like so. Okay, they're loaded. You get some warnings, you don't have to worry about it. Maybe important, the here package says like here starts at this tutorial thing. So that's good. That's what we want. Okay, so well, let me change this a little bit. Listing all data, listing all data. Okay, so we're gonna first read in these two vowel harmony CSVs. How do we do that? Well, we say, well, we're not gonna read them in, we're gonna list them first. Basically, so from the FS package, a directory list where, well, we start here. Here is where the R project is. Then we go to data, then into vowel harmony. That's how that works. And then we also want everything that ends on .csv at the end. Why am I saying this? Well, sometimes you get like these zip files or something that Pavlovia spits out, and we don't want those. We just wanted the CSV files. So if we do that, you can see that there's two files here, right? This long thing. Don't need to worry about it too much. Also for this harmony, where I just copied it, I changed this code and then also listed it out here. Okay, so the best thing to do when you want to clean data in general is to first figure out, assuming that all data files are kind of like uniform, is kind of figure out how one file works. So let's look at the first one, which I call test file. So the first one of our harmony is this one. The first thing you'll probably want to do when you want to change it is like to read in the data into R. So before we just listed it, we just asked like, give us a list of all these different files that we will need to read in. Now we want to actually read it in with the read CSV function, and we put it in something called read in data. So this basically is the same kind of like block thing as we saw before, right? So you can see, for instance, here is like the step 1, and then step 2, like NAs, but then suddenly step 2 will appear somewhere here, for instance. So success, yes. Okay, what we'll also do is when you have those lists of data, these lists of the data to read in, they also contain something like a vowel harmony and vowel disharmony in this case. So it's good to grab that as well. So as like a variable, so you can later on like add that to your data frame. So in test file, right, we want to extract whenever it says vowel harmony or vowel disharmony. So how is this read? Well, this is vowel harmony, but sometimes the group of this can also be present. Whether or not it's present, like we want it all. And that's, I call it major group, but and like also success. Okay, good. Let's first inspect once again. So with the view function, once again, you can see like we have those blocks of data. So that's good. I'm now gonna like comment this out so it doesn't run every time I run it. Okay, and we have those read in data, right? Like that's basically the whole CSV that's been like imported. Well, now it's best to like basically clean per block, but always keeping some kind of like identifying columns like the participants. So if we start with the read in data, I have like these things, for instance, like welcome begin keys, like there's probably like a welcome screen, like welcome at the experiment, or our ethical number is blah, blah, blah. Not important, you can just leave it away. You can just take it out. What do we want, for instance? I like the examples, like the training round, like, especially if it's the same for everybody, like you don't need that anymore. What is important is the participant, which is kind of like a unique identifier, right? The date might also be important as like an extra way of identifying them. Because let's say somebody, like two people like start at the same time, or maybe by accident, like a participant number like has been assigned the same way, but the date is different. So you know, like it's good to have like the second kind of like a differentiating manner. Things we will also need, for instance, in this step is step 1, this rep num. So that's like the order in which items were presented. At this one, it's this one, 0, 1, 2, 3, 4, 5. And you can use a select function to basically like make this sub selection, right? And then say like what you want to call it as, well, what you want to name this this thing. So like we call it step 1 order, or the stem suffix, those kind of things. So this really depends on like on your own data, how you like call things, how you like rename it, but like try to give it meaningful names that you can later on like easily, you can see step 1 order. Oh yeah, that is the order in which these items were presented. Okay, next, mutate. What does mutate do? It introduces or changes new columns. So in this case, because we want step 1, so I'm adding an extra column called step 1. Well, I'm adding a column called step, and the value of it is step 1. So you can see, and like if I just go down this list, like it's so empty on the left side. But basically the first block we just got, and also like here are some NAs from the first ones, like maybe we don't need that. So like we can filter them out by saying like, we want to keep everything that is not NA in step order. You don't have to use step order, but like this is a good one to use. You can also use step 1 suffix or step 1 monster that we created. Just don't use step 1 or participant, because then these will still be there. Okay, and then maybe let's see what this one does, because I wrote this a long time ago. The last one is for extracting. Yeah, so because PsychoPy or Pavlovia, what it spit out was like these kind of like audio slash Getty.wave things. They're very hard to like to read, right? And like sometimes .png. So this is basically a regular expression to filter out those things and just keep like this part, the meat that we want. So basically, we want all characters, one or more, preceded by this kind of slash thing, okay, and followed by a period. I hope you can. You don't have to do it, but it's really just about cleaning it, right? So like, it's cleaner that way. So maybe regular expressions is difficult. So I would suggest you look for something like RStudio cheat sheets, regular expressions, stringers. Or in fact, I might look for you right now. Studio cheat sheet strings. So you'll get to the cheat sheets. There's many. The one we want is, well, you can use data tidying, but like I think it's more useful for the stringer. So that one will show you like which strings, like which functions you can use to like match things. And also it has like a list of how to write regular expressions. Let's see if I can find it on my computer. Strings. Yes. Okay. So especially like this page, right? So like a period, for instance, needs to if you want to match this one single period, you need to write this, for instance. If you struggle with this, like also feel free to contact me. I will try to help you. Okay. So for step 2, we basically do the same. We start with getting data of this one file, right? We do the basic treatment. So like we select the things we want. We clean them in such a way that, well, I can show you. So this is all the step 2. So this is what I was talking about. So like what needs to be clean here? Well, obviously we don't want like all the audio and wave things. We just want go no ro, re, and go no v, which were the 3 options, right? One has vowel harmony, one has vowel disharmony, and then one is like a dummy answer or something like a foil. So the chosen letter is A, B, C. We don't want to circle to A, like that's not useful for us. Okay, so what needs to happen then? We chosen letter will be string extract from chosen letter, basically something that will capture A, B, or C. So basically it is the options A, B, or C, followed by followed by 2 characters at the end. Yeah, so 1 character, 2 characters at the end. So that will be transformed as well. And you can see how that worked. A, B, C, okay, good. Also, we take out all the ones we don't want, like before, and we do the same kind of function here to clean the data from this like audio stuff. of course, now we have A, B, C. Let's run until here. Okay, so like let's run until here. We already know it's step 2. So like we finished with this block. We now have this letter. We have here 3 choices: step choice A, step choice B, and step 2 choice C. So in this case, it's A. So we want to basically convert this chosen letter into like this answer, right? So we're gonna mutate the chosen monster variable, right? We're gonna make that variable. Well, if the chosen letter equals A, then it is this answer. If it's B, then it's this answer. And if it's C, then it's this answer. So, okay. So A was Gonoro, C was Yukuro. Okay. And of course, because this experiment was also very interested in like whether or not they got the vowel harmony right. So the next step then is basically trying to figure out if this is a vowel harmony, harmonious or disharmonious answer. So what I did to solve that problem was basically make a new variable, step 2 stem round. It make as many variables as you want, like no worries. So if we detect in step 2 stem, that there is I, E or A at the end, I or E, right? At the end, that's what $sign means. Then the roundness would be, the stem would be unround. If not, it will be round. So that's what this if-else function is. Then we're gonna look at the suffix, right? So of the chosen monster. So ro, re, or v, or vu. So in this case, there's only basically one. Yeah. So if it ends on a, chosen monster here, for instance, this one, then the suffix roundness would be unround, right? A otherwise would be round. So making those 2 columns. Okay, so round and round. And then finally, the correctness, whether or not this is correct or not. So first think about the harmony condition. Later on for this harmony, we will switch it at the end. So you can just use this kind of like way to like calculate it. Step 2, correct. So if a new thing for step 2, correct, in the case that we find that the step chosen monster has this like foil or dummy suffix like v or vu, then that value will become 0. If we find that step 2 stem round is not equal to the value of step suffix round, so meaning like we have an like let's say we have like a rounded one here and unrounded here, or rounded unrounded and rounded, then they did not get it right, so like that they failed, so that would also be 0. But in all other cases, meaning logically like it would be like this equals this, and true, like it will be 1. So this block we kind of like dealt with, right? So we have our participants, ugly number, step 2 order, step 2 stem, etc. Finally, we get like a value here. And it seems like this person was really good, like everything correct. Well done, Mr. Or Mrs. 26, 2021, 12. Okay, so for step three, in step three, like we kind of like tested them like to see like which ones they would choose. So once again, the basic treatment of the read-in data, this one file, select participants, and then like rename the things you, well, select the ones you want, rename them by saying like step three order equals this thing from the original file. Okay. Mutate, introducing this like step variable, which is actually very crucial because that will be like how you filter things in the end. And then filtering out the NAs. Once again, doing the same kind of like which one did I choose, like kind of like a thing we saw above. Extracting like audio things and wave things. And then finally, once again, assigning like if they chose A, then it's step choice A, B, choice B, C, choice C. I should warn you, or I should probably say like, don't write this like anew every time. Like the good thing about this kind of like process is you can just copy a lot and then just like amend it to like every block. For step 4 is actually basically the same as step 2. So also written data of this one file. Once again, the basic treatment of like selecting participants. Always select like an identifying column, right? Participant in this case. These things, okay. Introducing the new variable, taking out the NAs, changing like the ABCs, like with all the brackets and whatever, to A, B, or C, taking out audio and wave from all the fluff there, then changing this like ABC into like a real answer you can study, doing the same kind of like roundness and suffix roundness thing, and then giving a score. If this was hard to follow, then please feel free to rewind and like watch it again. Finally, there was an AXB test. So basically, we asked them to rhyme words. So if you have a syllable called like May, does this rhyme with gay, guy, or goy or something? And if they like weren't able to match that, then like that was a way of filtering out participants. So I don't know. I don't think you have to do that for this experiment, but this also could have received the basic treatments of like that we're well familiar with, right? Okay. Then let's see. I'm gonna restart just to make sure that everything runs. Then I'm running it up until here. Okay. So for this one file, we have done like all of the cleaning for all these different blocks. Now, of course, we want to put it all together so that we get something like this, 117 rows, like this one participant gets repeated all the time. You can see that like step 1 will change, right? Then it becomes step 2, step 3, and step 4. There are still a lot of like empty spots because like the blocks are still there. But because we introduced this step variable, basically it will be easy to filter later on. So how do we do that? Well, we have the step 1, we have step 2. We can fully join them by saying participant and step. And then add on to that with a pipe, add on to that step 3, add on to that step 4, add on to that step 5. And then what does that give us so far? Like something like this. But you can see that the date suddenly will stop. So it's probably useful to like basically fill out that date. So like every value here also gets like that date repeated. So you can use the fill function, date, and the direction is down. So like this will basically copy this one value here all the way down. Then remember that we calculated like, or that we extracted from the file name, whether or not it was vowel harmony or vowel disharmony. And we had like the variable called major group. So we introduced a new variable called major group, and within a data frame, so like, and it gets the value from this thing we extracted here, which was also called major group. So this may be a little bit confusing, but because it's the same, but doesn't matter too much. Where are we here? Okay. And then finally, you can change the order by saying like, is this vowel harmony or disharmony, participant, date, step, and then everything else, which results in this one data frame for this one file, which looks much cleaner than like all the mouse click and whatever names from before. At least now we know what we're dealing with. Okay, so we did this for one file. Remember, we have the list of files. We know like which ones for vowel harmony, which ones for vowel disharmony in our case. Now, the easiest way is to basically scale this to all other files, right? So we're going to do that by making a function. And like in R, you write a function by saying like, basically by saying something like my new function variable names, variable 1, variable 2 or something. This is how you write a function in R. And what is a function? Basically like all of the things we've been using before, right? So like, let's say like var1 plus var2. And this is a new function. So my new function of 1 and 2 will give you 3 because it adds them on. So what you need to do basically is copy all of the preceding chunks into a function. I call the function cleanup. And what will I give it? Well, I will give it a CSV file, right? Every time. So like, okay. So it basically make it go loop over all of the CSV files that we have. Okay. So, and I already copied everything. So basically it is written data, read CSV, and this CSV file instead of like test file that we had before. Major group, CSV file. And so that read in data, all the rest didn't really change because I wrote it so like that I only need to change these two at the top. But if you have like many, if you still have like this test file like in many places, for instance, like make sure you can like, you basically change it in every place. You can just use the Control F function, right? So I step 1, I place in here step 2, step 3, step 4, step 5, and then putting it all together. So I want you to know that like this doesn't come like super easily. Like it will take some time to basically work out the like how to deal with one file, and that's okay. That's part of the struggle. Like it's really important to clean your data well, so it's easier to do the next steps. Okay. So once we done that, I like using the library TikTok because it counts like how long something takes, but you don't really need this per se. So I'll just comment it out. It will tell you how many seconds something lasted. Now we're gonna map data frame row wise over all of the files we had with this function. So once again, we have like the list of, well, I can just show you, right? Like the list of items, right? So like of files, so like this one, right? The CSV file and the CSV file. For the harmony ones, we want to basically go over, go to every file and then clean it with the cleanup function. And so while it does that, like it will basically add all of these row wise. So like adding in one bottom, like horizontally, right? Like this. That's what the R means here, to each other. So if I, of course, I didn't run the function, so let's do that. And it doesn't matter that this is long or like not very beautiful or whatever. The important part is that it works. So let's see. Okay, that's done because it's only 2 files. And now you can see 234. And if I would ask like how many participants, for instance, it would give us two rows. So for this harmony, it's the same. Instead, except for the list is this one, right? So we run that as well. And then we can bind them together also. So we have like a thing called together. If I ask like how many are there in together? 4, so that also makes sense. Well, you don't need to run this per se, but you can. Okay. Now, as you notice, so these participant names are still kind of unwieldy, right? Like, and also maybe in terms of like anonymization, like it's always good to like anonymize your data. So in the cleaning stage, so you don't need to worry about it later on. If you do have to pay people, it's good to have like to basically extract that information now and like separately. And then the analysis data frame, like that's something that's anonymized. Okay, so we start with together, this new data frame like cleaned up. So what do? Well, we ask for all the distinct major groups like vowel harmony, all the participants and all the dates just to make sure. Like so, we should get 4 items. Yes, success. Then I have like a number because I know like it's 2, 2, so I could use this function. So repeated function, but if not, like well, there are other ways of like like counting like data, so like, that's something you can Google probably. And then so we did that one, and then I also add a condition. So a condition is we extract from a major group everything. Well, everything after the underscore, right? So like we want everything that's preceded by the underscore. So we want harmony basically. And then we do another mutate, a new variable, participant recode is, and then we add those 2 together. So string glue of the condition, which is the harmony plus this number. So what does that give us? Like this number we introduced, 1, 2, 1, 2. Condition, harmony, harmony, disharmony, disharmony. We want something called like harmony 1, harmony 2, disharmony 1, disharmony 2. Okay, so of course, because we have harmony condition and disharmony condition, we just use the same function to calculate everything. But of course, what counts as like correct depends on the condition, right? So like in a disharmony condition, we want them to learn that like the wrong answer is the one that has like the same roundness. So like pomo ro is wrong in disharmony condition, pomo re is correct. So what needs to happen here from this together file, step 2 correct. Well, if our major group is vowel disharmony and it's and the correct answer is 0, then we want 1. If it's the same conditions, but it's 1, then we want 0. So we switch them. And in all other cases, i.e. when it's like a vowel harmony, then we can just keep the same value. but maybe because like zeros and ones will be changed, so like we might need to change the FOIL back. So that's what happens here. We do the same for step 4, so it's the same code, just step 2 replaced with step 4. And then we add in this recoded list, right? So we have like this participant number, right? And the date, so like we can say like participant recoding, select participant recode. So this part we will be adding based on the date. So that's like the communal column, right? So you can just map them like this over each other. Then we don't want the original participant anymore. We want, so we take it out with select minus participant. And then once again, we say select major group. Now participants, we want the participant recode to be called participant, the date we also want to keep, and then everything. And what does that give us? Together 2. And together 2 looks like, sorry, we have our participants, right? All the rest is actually the same as before. Yeah, we can just count. So we had like 2020, so like that means 40 items in total for that's something like some checks you can do, right? Did it work? And then finally, we want to write a CSV, like the output. So we have all these different CSVs in the beginning. We went over them, cleaning them, putting them together for harmony, doing the same for file disharmony, adding them together. And now we have this one data frame. We just want to output that as a CSV for analysis. So writing it, file where, so we start once again at the R project, then in the data, and then the name will be cleaned up.csv. And that will give us this one, which is like what we wanted to achieve, right? So well done, team. I hope you're still with me. Okay, it's okay to take a break right now, but the analysis will happen very soon. And we're back. Okay, so we have done the cleaning. We've gone from we've gotten the data from Pavlovia. Oh, so many CSV files, so many other files. We went through it, cleaning it thoroughly. So first for one file, then scaling it up with a function, and then looping over it with the map function. Then finally some posts, like posts changing things, like the changing like the zeros and the ones for the disharmony condition. And then finally putting that all in one file, which can easily be shared and inspected. It might be good to add also like a date to it, just to make sure that if you run this again, like you don't override, or like if you change something. So like don't, you know, like it's okay to add like what is like 12th April. So it's good to add something like this to it. So, you know, like you can see which one is the most recent one. Or when you're done with this, like basically like, you know, like commenting it out, so like you don't accidentally run it again after you change something. Those are like good handy tips. Okay. So that's that. So assuming we have the cleanup data, what we want to do now is to do some basic stats. I also have a script for that, so that's analysis. Let's restart R. In this case though, I'm gonna use like the original cleaned up version from a previous project, which has just much more items, so I just call it clean up more. instead of those four files, now there's, what is it, like 90 files like in it. So like it's hard to open it like with a viewer on Mac. Anyway, I'll just show you. So some packages for this one. So like it's a separate stage, right? Also, once again, tidyverse here. And then for testing, LME4 Elmer tests is good. And then for visualization, you can also add on like ggpubber. Okay. So let's read those in. Let's go to the library. The library is open. Okay. Once again, original data is read CV. Here, data cleaned up more in this case. And if you inspect it, you can see there's like 10,000 rows. You can also use like a function like skimmer, skim original. So from the skimmer package, the function skim, which gives you lots of information about, let me change my window here. Okay, you can see how many rows there are, how many columns, which type they are, if there is anything missing or not. And of course, there are lots of things missing because like we had those NAs because of the block structure, right? Which is okay. We know how to filter because we have the step variable, so we can easily filter. Here are some other histogram kind of things that it calculates. That's something you can use to inspect your data. Okay. So what do we need to do? Well, you can count things. You can see it's like not like well, it's not super nice in terms of it's because I did by correctness. Okay, this is actually like you don't have to do this step. There's some exploratory things from before. What you do need to do is basically get some descriptive, like summary statistics. So we start with original. Okay. Now we want to select a major group up until step. So these ones will be good, always keeping like some kind of identifying columns. These four are good. And then everything that starts with step 2, because that's the one we'll be doing some statistics for. So you can use the selector, starts with step 2. But all of these NAs are still here, right? Because we have this block structure. So now we want to say, well, we want to filter. We've chosen like variables. Now we also want to like make sure we get the right block. Filter step equals step 2. Okay. Now we get 1,800 rows, and you can see there are like no NAs whatsoever, so that's good. We group by major group and participant. So per participant, we want to and per group, we want to add we want to know like how many correct they are. So since we had 20 trials per this group, right? We can count like how many they had correct. So like 1, 2, 3, 4, 5, and in total, like divided by 20. So summing within this group divided by 20, and that will be a number that will give you like a double, right? That's like that tells you the percentage of correctness, and then on group. So what happens here is 95% correct. Well done, person. Here is the one they didn't have correct. And you can see, putu re, like they messed that up in the harmony condition. So that's the first thing. We put that in something called descriptors to prep. Okay. Then you can also get some mean and standard deviation, but I guess the one we were really looking for is this one. we want more things. So we have this basically this little group of items, right? Like 1,800 rows. Now we go and like already like we have the correctness at the percentage, right? So we need to do this first step. We also want to get the mean, the minimum, the maximum, standard deviation, standard error, something to look for the quartiles, and then the confidence intervals. So because we've ungrouped, we can group again per major group and then summarize all of these things, right? So like we want the mean of percent correct, the min, max, etc. So what does that give us? For these two groups, disharmony and harmony, we get like these values. Now, of course, we want to like maybe visualize that because like that's easier. And I think that's also what Dr. Doe wants. I use the ggbarplot from like ggcover, but you can also use ggplot or whatever you feel comfortable with. What will be on the x-axis? It will be those two conditions, right? Disharmony and harmony. So a major group. Y, we typically want the mean. So if I do it like this, does it already give us something? Yeah. So this is kind of ugly, right? So like, but like this is like basically what we want. So there's two major groups on the x-axis, on the y-axis the mean. Because this is kind of like ggplot-like style, so we can add like more arguments and also add more layers of things. So we want colors to be depending on this condition, major group. Palette is basically like what kinds of colors. I chose the ones from the journal Lancet, which comes in this package. I don't want a legend or anything. With like just that's about like changing the size of these bars. XLab, like I don't need to know like that it's major group here or like on the y-axis. Like I just like I know. Very typical. Maybe like a title. So in this case, main for this function. Correct answers per condition in step 2. So let's do it up until there. Looks much better, right? Already. So of course, we want error bars. So we can add geom error bar, which is typical ggplots like syntax. So the aesthetics are once again this major group. Y minus is confidence interval minus confidence interval max. Width of the error bars. And then maybe some like nice like theme as well. So like adding these things. Oh, but this legend is kind of like ugly. So like we take it out. Theme legend position is none. And then maybe we want like a different scale on the y-axis. So like this is what I would think is more pleasing to the eye. And you can see that there's like no overlap between the error bars, suggesting that there is indeed like a difference between the two different groups in this case. We can also test that. So like if we have this descriptive prep data set, we can do a t-test. So step 2 correct, meaning like there's two outcomes, like either it's like 0 or 1. Incorrect, correct. Can that be predicted by major group? So by this condition, let's run the t-test. Okay, p-value very small, so that's good. Okay. We can also do like some basic modeling. So once again, you can also run like a model. So like first you need to prepare like some kind of like data frame. So yeah, we start from original, We select the columns we want. We select horizontally, like the NAs, for instance, we don't want. So by saying we only want things that have to do with step 2. So that's model prep. You can also check, right? Like 90 rows, that makes sense. 45 harmony condition, 45 disharmony condition. If you just run a generalized linear model, so something that has like 0 or 1 as outcome, is the same formula as for the t-test. Step 2, correct. And can we predict step 2 correctness in terms of this major group, in terms of this like a condition with this new data or with this data set? Run it, and then the summary, we see like once again, because it's actually the same test, the p-value is the same, 1.23 times 10 to the minus 5th or something. I don't know how to say this in English, but you can read the scientific notation here. So yes, very much like important, very much so that there is like an effect of this condition. Standard error is also pretty low, so that's good. Now, in your case, what we want to predict is actually the correctness. So like once again, is like ones or zeros, right? In terms of naturalness. So that depends on which kind of which of the 3 groups you are in. So this is something you need to like think about, like what does that mean? Which column corresponds to this? So like the basic formula is the same, right? Correctness in terms of naturalness. Family is binomial. Data is the prepared data frame that you made. So like in this case, like step 2 model prep. But because there might be a varying factor, so you need to do a mixed effect model. So like we are interested in like the fixed effects, like what is the effect of the condition, like of naturalness, I guess. Or in this case study of this major group, so like harmony or disharmony. But there might be like a varying effect for a participant. You know, like some participants are good at it, sometimes they're bad at it. So trying to get that into the mix with this kind of syntax, so like plus and then open the brackets 1 over participant. You can get like a by, what is it, like a varying intercept per participant, right? You can include that into the model, and like probably it will influence your like significant level. But if it's still significant, then you know, like it's like a more correct model because you've accounted for like this varying variability between participants. Note that things you add here, like they always have to be categorical data. So like that means like no numbers, but like item or like condition or maybe language, you know, like those are good things to have to put in this category. So instead of using this GLM function, which works well for just fixed effects, because we add this random effect of participant, we need to use the GLMER function from the LME4 package, LME4, to run it up. So it has been run. And then what does it spit out? Well, we know that like this variability for like what's it called, participant on the participant level has been taken care of. But even if we take care of that, like take that into account, we still see a significant effect of the harmony condition, or like versus the disharmony condition, which is the intercept. So this is kind of like the basic workflow of things Yonga wants, Dr. Do wants you to find out. So like fetch data from Pavlovia, then clean it, visualize some basic statistics like this one basically, or in numerical, like if you want, like numbers, because this is what you probably have to report. Do some tests, like you can do a t-test between those two things. And then like a model that includes this kind of like a variable effect or like a random effect, like participant. I would say try to get as far as you can. If you have any questions, like at state, like in any stage, like by next week, like something, if it's something practical, like, oh no, I don't know how to write the regular expression or something, feel free to contact me. I'll try to work with you through it. And in any case, good luck with analysis. You can do it. Thank you.